Syed sir, welcome.
Good evening, sir.
Yes, sir. Good evening, sir. Thank you for joining us today.
My pleasure.
Yes, sir. So just one more minute. Exactly by 6 o'clock, we'll start the program, sir.
No issues. I will wait. No problem at all.
Deepika, we shall start the program part.
Yes, sir. Good evening, everyone. I am Dheeraj, Webmaster APS I will be hosting today's session. Welcome to the day 2 of our training program, where we will dive into the topic Introduction to CST Studio Suite. It's my pleasure to introduce Mr. A. Syed Ibrahim, a highly accomplished professional currently serving as a regional manager for academics in South India at Advanced Reality Solutions. Mr. Ibrahim brings over 17 years of experience in academia and industry with a specialization in computer aided design, electromagnetic simulation, and power systems. His impressive career includes roles as a technical lead and senior consultant in both India and the Middle East, along with numerous academic positions where he trained and inspired future engineers. Mr. Ibrahim holds an ME in Power Systems Engineering and is well versed in tools like CST Studio Suite, AutoCAD, MATLAB, and EDAP. Today, he will be introducing us to CST Studio Suite. His extensive knowledge and practical experience make him the perfect guide for this session, and we are thrilled to have him here. Participants can feel free to unmute and clear their doubts if any during the session, and also you can post your doubts in the chat section. We will also have a short break in between around 6:50 p.m. and the program will resume after that. I would also like to extend my welcome to Dr. Malati, Professor, Department of CEG, for gracing her with her presence. Thank you, ma'am. And everyone, please join me in welcoming Mr. A. Syed Ibrahim. Handing over the session to you, sir.
Thank you, Mr. Dheeraj. Good evening, everyone. It's my pleasure to be a part of this wonderful event. Great thanks to Professor Gulam sir and Professor Dr. Malati ma'am as well. So I'll be handling the session today and 4th of this month, I mean day after tomorrow. So during these 2 days, let me introduce you to some of the simulation technologies. But before that, what is this simulation? Why do we need this? So today we'll have a short view on the need of such simulation technologies, after which we will dive into a particular tool, which was already mentioned by our professors. It's a CST Studio Suite, which is really useful in communication field nowadays. So this particular tool has numerous modules inside. So we shall go one by one. That is the plan of Professor Maladi and also Professor Gulam sir. We were having a discussion like 3 weeks ago to impart this knowledge to the students. So I believe that this would be just the beginning. So we shall start with need of simulation followed by the CST Studio Suite. And shall we proceed with the session, or shall we wait for some more participants to join?
No, sir. We'll begin the session, sir. We'll start.
Great, sir. Great. I will share my screen now. Is my screen visible now?
Yes, sir. Good to go.
Great. So like Professor introduced, I am Syed Ibrahim from Advanced Reality Solutions. We work for Dassault Systems, which is located in France. The headquarters is at Paris. So this is what we are going to deal with: antenna design and electromagnetic simulations. In particular, we are going to address real world industry demands. It's my pleasure to join, and I will hide this. Before we get started, let us see what is this industrial revolutions, because as the revolution changes, the technology moves forward to another level. So when we started at industry 1.0, we all have a little bit of knowledge on industry revolutions, industrial revolutions. Industry 1.0, 2.0, and 3.0. At 3.0 is the place, I mean, is the period where computers have started to give their major parts, from where we started to have automated production as well as semiconductor electronics also. In industry 4.0, which happened around 20, I mean, after 2000, after the year 2000. So until 2020, there were numerous improvements in industrial revolution 4.0, where we have heard about lots of cyber systems, internet of things, industrial internet of things, encrypted platforms, cloud services, networking, machine learning, which is a part of artificial intelligence, I would say. Because another part is deep learning. So artificial intelligence has two subdivisions. AI has two subdivisions. One is ML. We call it machine learning, for which we have numerous algorithms. We can train any machine by using any of the ML algorithms. Whereas the other one is deep learning, which is also part of AI, artificial intelligence, and for which we have only one algorithm, that is the common one, which is called a neural network, which we might have learned using fuzzy logic and other training methodologies. But the learning methodology adapted for deep learning is neural network. So what happens with 4.0 is only the automation and data exchange. Automation happens with all the existing machineries that was produced in industry 3.0, and the data exchange happens with help of IoT networking stuff, like cloud platforms, encrypted open cloud platforms. As such, lots of cloud platforms are there. So using those platforms, we can store whatever information we process. For example, we can say we would have heard about Arduino boards, ESP32 board, ESP8266. Of course, ESP8266 has some limitations compared to ESP32. These are all coming under IoT. These are basic boards which can connect with internet. Arduino may not be able to connect at the moment, but there are some modules. So forget about Arduino. The other boards, ESP32, ESP8266, we call them Node MCU, ESP8266 boards. So these boards have the ability to get connected with internet and transmit the information that this board processes to the cloud platform. We would have seen ThinkSpeak, which is part of MATLAB. We could have, you would have done some experiments like measuring soil moisture or some other basic experiments. The logic behind Industry 4.0 is two things: automation and data or information exchange. So that happens over here. So after a certain time, like after the year 2016, the International Telecommunication Union, ITU, it is a global organization who work for this communication related stuff, where they have launched a standard RTU. If I'm right, it's RTU 1.4 or something. I'll give you the clear number. What did they do? They started doing some encrypted data exchange, where they started using 128 bits of advanced encryption standard. This standard has two different modes of activations. So that is coming under IoT, and there are lots of encryption protocols. When time permits, we will discuss about IoT and its encryption standards, maybe in the later sessions. And This is what happening with Industry 4.0, where we are so comfortable with data exchange to the cloud platform. Cloud platform is a virtual place where we can store and retrieve informations. We can give some examples for cloud platforms like Google Drive or Apple Drive or whatever. iCloud, you can say. So these are all cloud, which is a portion in internet which can be accessed using particular credentials like login ID and password. We all know this. But in Industry 5.0, look at the bottom of Industry 4.0. I've mentioned the machine learning. Actually, we teach some of the machines to follow the instructions that are loaded already in its hard drive. So that's what happening at 5.0 also. We will be collaborating with some robots for all the processes. And during that time, the encryption level, I said in AES 128 for Industry 4.0, but for Industry 5.0, since the human and robot collaboration is there, between robots, the encryption should be really, really high, for which it is being planned. The ITU, International Telecommunication Union, is planning to have 256 bits of AES, which is actually available with our online payment platforms like Google Pay or Phone Pay, you would have heard. I can say Paytm, whatever. It is available. You can check the application, that app's details. So the 256 bits of AES represents additional layer of security as long as the communication is concerned, therefore ensuring data security. So this is what the plan for Industry 5.0, for which we will be requiring lots of trials. If we are going ahead with some design, we can say, for example, assume that I'm an electrical engineer or electronics engineer. I am going to design a device to absorb electromagnetic waves and convert it into equivalent electrical signal. Then I should design it first. So this simulation, the design requires simulation, because we cannot buy products directly and do the process. I'll explain. I hope it's clear until Industry 5.0. What we should keep in mind is that until Industry 3.0, it's okay. It's history. But 4.0 is what happening now. 5.0 is future. So 4.0, two processes. You can say automation and data exchange. That data exchange happens between the real world components and the cloud platforms. The cloud platforms refers to the place where the data are virtually stored and retrieved using credentials. 5.0 is collaboration of human and robot for all the applications. You take your pick, any application, medical field or defense, production, teaching and learning, everywhere robots are there. So 5.0 is the future thing that is being planned by all the industry professionals, senior scientists, and all the institutes, senior professors. They are working towards achieving everything in line with the requirements of Industry 5.0 revolution. It is going to be a short introduction about this company, Dassault Systems. Actually, they have numerous industrial clients, but their objective at the moment is to connect with institutions like yours, top-notch institutions, from where they could get people who are really handy with their software tools, because they supply some softwares to the industries, leading industries. I will show you what are the industries. This is some basic information about Dassault Systems. It is located in Paris, Boston, and Shanghai. These are the headquarters for different parts of the world. They have 72 research and development laboratories and 180 3DS offices, which means the complete setup. You will come to know what is the meaning of this complete. I will show some of the slides so that you can understand. This is how it has begun. In the year 1981, they have started doing 3D designs. In 89, they started doing digital mock-up. And then The product life cycle management has come in the year 1999, that too for a car manufacturing company. In 2012, they've launched 3D experience platform completely, where you can virtually get into an environment and feel it. You know, for example, I can say you would have heard about augmented reality and virtual reality, AR/VR. Augmented reality, I can say best example, Amazon online shopping platform, where you can virtually place your product. If you are planning to buy a bag, handbag, you can literally place it on a table in your home or in your office simply by using that option 360-degree view. That is AR, augmented reality. But when we talk about virtual reality, you'll be given a lens to wear, like a goggle or glass over your, will be covering your eyes, and the belt will cover your back of the head. So you'll be wearing a lens. Use that lens is coupled with your computer or laptop, and you'll be given a couple of joysticks on your hands. So with that, you can experience, you can go into the imaginary world. You will be a part of that world. So though you are standing in your home or somewhere in the, somewhere in the laboratory, using these gears and lenses, you will feel that you are into that virtual field. Example, you can say some car races or some shooting games like Call of Duty or some other games. Boys and girls would have experienced it. I had a very good experience on that. When I try to play something, I use my gears and go into that field. I will have a feel like I'm a part of that. The things are around me, but it's not so. Actually, I'll be playing it in my home. So when I start wearing all these gears, I will have a feel like I'm into that. So this is entertainment part. When we talk about industrial requirements, assume that I'm designing an aircraft's engine or an aircraft structure. I can literally get inside that aircraft and see what is happening with my design. I can check my design's flaws. So that is possible with this 3D experience platform. So that was launched in 2012. But in the year 2020, we all remember we were struggling a lot to fight against Corona. We remember that. This is a validated information that I'm going to tell you now. Creating or producing or discovering a vaccine will not happen in 1 or 2 years. That's not possible. When you see the history, it took nearly at least 10 years to discover a vaccine for any disease. But you see, for Corona, though it was a new disease by that time, around 2019, end of 2019 and the beginning of 2020, there were lots of trials. So they find that the doctors, senior doctors and scientists, they find a new medicine. They wanted to test it. So it is not okay to test it on some human being. We all know that. So what did we do? What Dassault system does? They created virtual twin. Virtual twin, as you can see the picture, it holds the information about the human. Assume that I'm a patient and I have certain amount of blood pressure, certain amount of heart rate. We call them vitals. So all the vitals, all the medical related biomedical informations from my body is absorbed by the doctor and stored on his computer. Now this information is shared with Dassault system with proper permissions. So the information is shared to Dassault systems, and Dassault system takes this information using a software tool that is called Medidata. Keep in mind, I will tell you about this in the later slide. It's Medidata, MEDIDATA. This Medidata will hold the record of information, biomedical information of different patients. Actually, I am at home, but my information is with Dassault systems. They are going to test me with new vaccine. Now, my anatomy is created, my virtual twin, like this person on the screen you can see. Like this, I hope you can see on the right side. Like this person, my human anatomy is created, and that is me. And the medicine, the vaccine that was discovered, that is also converted into software modules, for which we used BioVia. Make a note of it, BIOVIA, BioVia, which has multiple modules in it for design, validation, lots of sub-modules are there. So using BioVia, the medicine is created. Using virtual twin tool 3D experience platform, my anatomy is created. Now they started simulating results. So using this, the vaccine was discovered. Actually, we did not support the entire process. We supported nearly 70% of this vaccine, corona vaccine discovery. It is an official information. You can check. So where are we? Where are these simulation tools? You can see everywhere. Consumer goods, transportation, aerospace, marine, life science, industrial equipment, high-tech devices like telephones, mobile phones, other stuff, engineering, infrastructure, general business service, home and lifestyle. You see everywhere this is possible. Let us assume that we are working on aerospace and defense. So what is the role of simulation technology over here? It is really easy to understand. You see the structure of this aircraft. You would have heard about Rafael. Yeah, Rafael. Dassault Aviation. In India, in our defense and aeronautical and aerospace research institutions in India, and also our defense unit, Indian Navy, and the Indian Navy comes under marine and offshore. Indian Air Force, they use Rafale, which was designed by Dassault Systems. So we all know about Rafale. So what are the parts of this aircraft? So when we talk about the role of electronics engineer, the guy who has completed ECE, the role of a person who has completed electronics and communication engineering, he or she can work in aerospace and defense in a particular field, like you can say instrumentation, because an aircraft will have uh, five different systems or five different sections. Number one, the overall structure, we call it the overall structure, and the engine bay and the electrical system, the electronics. Under electronics, we have two systems. One is communication, the other one is uh, instrumentation. All right. So we can, and a guy who has completed EC can work under these verticals. Today and tomorrow, we'll be discussing about how is this useful in terms of communication. So when we talk about communication, all we remember is antenna. So antenna should transmit an information from one circuit to another, and it should receive the information from another circuit to the one that is already sending the signal. So transmission and reception both should take place. I mean, the antenna should perform both operations. So this slide is giving you an information about the 3D experience platform and its uses. These are all the places or the field, you can say 3D experience is having its roles. Have a look at this picture. This is just a glimpse. It is only a reduced information, or it's only a sample, I would say. These are the brands that I know. There are more than 1 lakh customers across universe, across globe for Dassault systems. These are few of such applications. You see, aerospace and defense, Boeing is using, Dassault Aviation, Airbus, Safran. You can see lots of aerospace and defense clients are there. You can go to their website and check what Dassault system is doing with them. In transportation and mobility, we know most of them. Toyota, Ford, Opel, Renault. You see, take your pick. Top companies are there: Jaguar, Tesla, Mitsubishi, BMW. What are they doing? They are supporting in various aspects. We would see what are the aspects, because Dassault system does not provide any hardware. Please understand, they are providing only simulation tools. So under simulation category, there are numerous tools. I will show them one by one. But before that, we should understand, why do we need simulation? So how can we develop a perfect product or process? It is possible only if we have a time machine. That means I am going to design a circuit Let us assume a simple amplifier. For example, my amplifier, after connecting all the components, resistors, capacitors, transistors, biasing this thing, that thing, everything, all done, everything is set. When I when I connect the input source, like it is 5 volt, I designed my amplifier to produce 10 volt. It's not doing so. There is a problem with some of the components. Then what can I do? I should replace any other component and do it again. So this is possible only if I could rework, which means I have to go back to the time, but it's not possible. Though you can replace the component, you will not get the time that you have invested, time and money invested on using the first line of process. Assume that your transistor has burnt. What can we do? No, we have to replace it. Otherwise, the circuit will not be a useful one. So instead of losing this transistor, if I could go back to the time, like if I assume that I was working at 5 o'clock in the evening today, and at 6:30 I have completed my design. When I run my hardware, when I give the power supply turn it on, the transistor got burnt. Then can I go to 5 p.m. again? No. Today? No, it's not possible. All I can do is I can simply throw that burnt or damaged product or element and replace it with a new one. But if I have a time machine, yes, I can go to 5 p.m. today. But in real, time machine is not available. So what do? We use virtual twin. That is, the virtual twin is the digital, you can see on the left, digital replica of physical things. Anything I've explained, this one. Do you remember? Virtual twin. The digital replica of actual physical thing. It can be anything: a car, a train, an aircraft, a television, an antenna, a circuit, whatever, or engine, or any part, turbine, whatever. It can be anything. And we can feed real-time data with that and perform simulation. This is what I'm saying. So why do we need simulation? Have a look at this. To develop a perfect product or process, we need simulation methodologies. So what are the industrial applications of such simulation? Product development, you can understand all these basic informations. Improving manufacturing efficiency, workforce, transforming supply chain, sustainable practices. This is something we should clearly understand. We are not using any carbon-free materials. That is not the meaning here. Assume that I am designing an amplifier in which the transistor has got burnt. I'm going to replace it with a new one. Again, I will run the product execution. Again, some other product may burn. What is happening here? I am taking new hardwares whenever required, which means I'm using the actual resource. So when you check the carbon footprint of such transistors manufacturing, it is some value. So I am avoiding everything. So I am driving sustainable practices by using simulations. So that's what the meaning is. How do I approach? Being the students of pre-final year, I hope you guys are from pre-final year or second year. The objective is to work towards your project, because that project will define you. Who are you at the end of 4 years of your program or 3 years for lateral entries? After the completion of your degree, who are you? The industry will see you based on many aspects. Your project is one among that. So before you even start working on your project, it doesn't have to be 100% hardware. It can be a simulation experiment also. Or you can make 50-50 or 70-30 as such. So your idea is important. So have a clear concept. You can see, conceptualize your idea. Justify your idea. You cannot say that I am going to fold the entire electronics department and fold it into my pocket. No, it's not possible. I mean to say, when you think about something, you should have a valid justification for that. You can say that I will design an oscillator which will resonate at so and so frequency, maybe 500 gigahertz, and the cost involved in the entire design is only 10,000 rupees. So this is something like a theoretical approach, but you should justify it. What kind of oscillator are you going to design? What about its biasing? What about its major elements? What about the feedback unit? And how good is going to be the gain? And gain in the sense the reliability term, not the technical gain, output and input ratio. I'm not meaning that, because the oscillator may not have input signal, as we all know. So these many aspects. How about its EMI, electromagnetic interference capability? It is something that neighboring circuit may have some electromagnetic waves transmission, so that should not affect your oscillator, and lots of environmental factors. So everything is coming under your conceptualization. You should justify every single point. And 3D model building with the available simulation tools. Actually, the CST Studio Suite is we are already planning to have more number of users on your campus. Professor Gulam sir is working closely on it. So building 3D model of your project is very important. So you can do it on the computer itself. Analyze and validate. What are all your inputs? You can put into that model in this step, and you can test it. Create digital twin. 3D model is just a dead body, I would say, and you are giving inputs to it, so it's becoming alive. And once it is doing its work properly, if your project is running well, then it is your digital twin or your final project, I would say. And okay, you have a very good project working fine, then you can approach industries with the help of your professors, and this project can be converted into a product. Every product is a project once. Okay, so this project, your final year or pre-final year project, can be converted into an industrial product with the due permissions from your professors and their guidance as well. So finally you will be having your product in one of the top industries. Okay, that happens with digital manufacturing. Even you can test your product, you can create your product using simulation tools. Before going for hardware, you can have a final product in your computer as a module, like you see some pictures here. This is a 3D view. This is not actually hardware. This is someone else is viewing this in 3D. Okay. So what are all the tools available for this kind of processes? We can start from the physical design. CATIA for the physical structure. You see the pictures on the right side. Here a PCB is also here. Basically, CATIA is a design tool. You can see computer aided design tool. It is a 3D CAD tool with which you can design all your hardwares. Even you can design. You see, this is for civil engineering, and this is for us electronics people, for automobile students, some other department, instrumentation people, mechanical guy. For all department students, wherever physical structuring is involved, we can use CATIA. GeoVia is a very useful tool for the people who are designing and working everything related to mines, maybe gold mine, coal mine, whatever. And this is even useful in construction of dams as well. So that is another tool. Simulia. Simulia has two divisions. One is Abacus, the other one is CST Studio Suite. I will explain later. So keep this in mind. The tool that we are going to deal, CST, is one of the members of this Simulia family. All right, keep this in mind. Delmia is for, you see, here we talked about digital manufacturing. So Delmia is for digital manufacturing. You can literally bring your industry inside the computer. So how is my industry going to be? I'll be having this thing here and this thing there, and my manufacturing will happen like this. Everything will be, I mean, shall be designed using this Delmia. You can see there are over 26 million customers. 26 million in the sense, you can see it's really, really huge. This is to enhance the 3D appearance of our product. You can see this. This is a simple chair, but see how many parts are there. How can you um, take them separately and enhance its appearance? And actually, not that we are not altering any performance attributes, but the appearance. As you can see, shape. Okay. NetVibes is something related with the sales and other marketing perspective. So this is also available with Dassault systems. So these are all simulation tools. I mean to say, Enovia. Enovia is a platform on which all other tools work. Assume that you have Android phone with you. You may have WhatsApp application, Facebook, or some other payment application. So these applications are like individual tools like 3D VR, Delmia, Simulia. These tools are like individual application. And Enovia is your Android OS. So for Dassault system tools to work, we need Enovia. Enovia is a platform on which all other tools run. Okay. 3D Excite special appearance only, but this is pretty different from 3D VR. Okay, these are all business models. You can see, you would have seen some advertisements with lightning strokes and thunderstorms. Some visual effects are there. I hope you can understand. So for that also we have a tool to enhance the appearance of our product. All right. I hope you remember this word BioVia when we were talking about the vaccine for corona. So there are two different modules in this. All right. BioVia has to separate very big modules in it. Right. We'll discuss about this later. I hope you remember this metadata also. Transformation of information. It has lots of information with it. You see, unparalleled clinical trial data. All the clinical trial informations are here. You see, that is the role of metadata. So what can you do with the Dassault system? You can have joint certifications. You can sign up for some specific module and get yourself certified by Dassault systems, which will increase your appearance across the recruiters. Since you're students, I'm talking about recruitment. Once you have a valid certification from Dassault systems or its technical partners like us, requirement of industries can be fulfilled, very easily. I mean, people will start looking for you. How does it happen? Actually, this is what we are doing in your college, because your college is one of the hubs of information, hubs of knowledge, we would say, one of the hubs of knowledge. We try to connect with your institution and we talk with the senior people, professors, and they organize events like this. We are planning for some hands-on trainings also in person. We will visit your place in person and deliver some hands-on training to enrich your practical experience, because you can have a different set of laboratories at your institution, and senior professors are there to teach you, but still what's missing is what's happening with the industry actually. That is what missing. So we would bring some examples of industry's problem, current industry demands. We will bring such problems with some solutions. We will teach you. So that is also possible with us, and we are planning for that also. In India, where are we? So this is an example where we have COE. This is Center of Excellence. You see, for design they have, for electric vehicle, mine engineering, agriculture and water technology. See, lots of different applications are there using the tools, simulation tools. It is not only related to some physical structure design and as such. No, this, like I said, where are we? See, everywhere. On the right side, you see consumer goods. Everywhere, Dassault Systems is there. So that's what we are doing. And I would like to give you some examples of first case study to understand the need of simulation. This was taken at St. Louis Hospital located in Paris, France. Airborne pathogens means some kind of germs or some unwanted particles. How do they trace them? This was happened at one of the dialysis departments in that hospital. I will show you. I hope you can see the screen. Can you see the screen?
Yes, sir. We can.
I am not sure about the audio of this particular clip, but still you can understand without the audio. I'll play it now.
Educational tool. We have been able to reveal the invisible. Us.
I hope you have understood something from that. What happened was they have a dialysis unit where 9 patients were treated, and at the end of the day, they were okay. But in the morning, they become fragile, which means they become so weak. The doctors were confused and the nurses as well. So what did they do? They approached Dassault Systems to give a simulation-based monitoring. So first, what Dassault System did was they checked with their ventilation system, and according to that, they designed this simulation arrangement for them, particularly for their environment. And you would have seen the results. What is actually happening? It comes from another patient. That means every patient releases different types of pathogens. So they started separating them based on that, and then they improved this dialysis process. So this is what one of the examples. So this is possible with simulation technology, and they're so happy to see that is available with their tablet, that Apple tablet you would have seen available with that. They have the entire tool installed in that. It is mobile. They can take it to anywhere, any department they can check. All right. This is what the example for need of simulation. All right. Now, let us see what is CST Studio Suite, computer simulation technology. All right. For which actually we deal with electromagnetic simulation. So what are all the tools that are available with Dassault systems? We'll see. I'll show you. Dassault systems. Can you see the screen? This is Dassault Systems official website, studios.com, under which now we are seeing electromagnetic simulation. So when you scroll down, by using electromagnetic simulation tool available from Dassault system, that is Simulia, these are all the benefits. So these are basics you can understand. And let me tell you the different products available. Look at this. So with electromagnetic simulation, what are all the possible processes? You can design antenna and simulate it, microwave or radio frequency filters and components, bioelectromagnetic simulation, electromagnetic compatibility, very, very important. That is EMC, because any product, you are an electrical engineer, when you go to industry and create or produce any product, it should pass this EMC test. Otherwise, you cannot release it and sell it. The company, the marketing and sales company of your marketing and sales department of your company will not be able to sell your product without EMC certification, electromagnetic compatibility certification. There are numerous standards for this and they will follow it. But that EMC can also be checked with CST Studio Suite. Signal and power integrity simulation, very, very important when we talk about some absorbers, metamaterial absorbers and the filters as well. Low frequency electromagnetic, see lots of simulation possibilities, particle, electrical machine, optical device. So these are all the processes of Simulia's simulation tools. And what are the different tools available? You can see CST Studio Suite. To get started, we have CST Studio Suite, in which we have nearly 25 different modules. I will show them all now. Opera, antenna megas for exclusive antenna design, like array of antennas design, WASPNet, FEST 3D, Spark 3D, and IDEM. So these are all the different software products, electromagnetic software products for electromagnetic simulations. Okay, so we'll start with CST Studio Suite. So role of CST Studio Suite in industries. So before we talk about role, I will show you what are all the tools available in CST. In parallel, I will just open this software also so that you can understand. I have this basic version installed in my computer. I have the latest version 2024. This is S2, which was launched in the month of August 2024, possibly after the second half of the month. Sorry, second half was around 18th or 20th of August 2024. I have worked on few examples. When I try to open this, I'll be asked which part of the CST software am I going to work on. You can see there is a compass which shows different verticals. If I click microwave and RF, I see these many options. That's what I've shown here. See, under microwave and RF, I have 6 modules. The first one is Is it visible? Can you read the document?
Yes, sir.
You have, see, microwaves and RF slash optical, 6 submodules are there. When I try to open antenna, you see, when I try to open antenna module, there are different types of antennas: planar, wired, phase, reflector type, resonator type, something, no, wearable antennas, everything is available. Possibly today, if time permits, we will start with patch antenna design. And when time permits, and if we could get some future sessions, which your professor Gulam sir and Maruti madam are working fine. We are working very closely to give you more hands-on. So we are working on it. We'll start designing this patch antenna today, which is used in our mobile phones. I will tell you how to do that. Maybe later today, or we'll continue in the next session, like 4th of this Monday, on Monday. So this is under antenna. When I see circuit and component, these are the submodules available. I can work on all these things. See, filters, waveguide couplers and dividers, coaxial connectors, lots of stuffs are there. And when I open radar application, see, these are all inbuilt. Under biomedical, see, what is this? Biomedical exposure, SAR. Okay. And optical applications, dielectric structures and plasmonic or metallic structures, periodic structures. So these are all the different modules, you see. So this is under EDA slash electronics, the second one, second half, I mean, second module in the compass or pie chart, whatever. So submodules are there. You can see. So you can count this. I'll do it in the software itself. If I open microwave and RF slash article, there are 6 modules, keep in mind. And here we have 5, 6 plus 5, 11, another 6, 11 plus 6, 17, 21, 27. So we have 27 submodules. All right. So if you have a knowledge on all the modules, it's good. Or you can focus on a particular one. Sir, I am planning to have very good knowledge on antennas. Yes, go ahead. Your college has software, and we are trying to expand it. We will support you. Technically, your professors and I will support. No, sir, I'm thinking about biomedical exposure. Okay, go ahead. So you have a focus. Where are you going to work? So when you talk about antennas, you should know who are all using CST Studio Suite for antenna design. Which company is using? You can take your mobile and straight away you can search list of companies using CST Studio Suite for antenna design. You will see top-notch companies. Even you can do it parallelly. Lots of companies, top companies are using. No, sir, I'm thinking about some other stuff. You see, you can say, I was so interested in one of these. I'll show you. I was doing labels. I was trying to design metamaterial absorber.
Syed sir, sorry for the interruption.
Tell me, sir.
You want to go for a break? You asked me for a break.
Yes, sir. Yes, sir. Shall I take a break for about 5 to 10 minutes, sir? Is that okay?
Yes, sir. No problem. No problem. You can go ahead, sir.
Great.
Okay. We can resume by 7:10. Is that okay for you?
Great, sir. Great. That would really help me.
Yeah, yeah. So, Deepika, please announce that we'll break now.
Dear participants, you don't have to leave the meeting. Just keep it on mute, and then you may go for the break. I see some of you have left right away. Like 3 people have left. You don't have to leave the meeting. Hold on. You can simply mute. Fine, fine. Please let me know when we can start, okay? I'll just wait.
Sir, welcome back. We can resume, sir. Students are already present.
Great, sir, great.
Yeah.
Thank you. I was talking about the modules, inbuilt modules in CST Studio Suite. So we were at this place, EM simulation tools by Dassault Systems that we have already seen. I will show you once again for your easier understanding. It's here. So these are all the.
Sir, the screen is not shared.
Just a moment, sir. Sir, is it visible now, sir?
Yeah, it's getting.
Yes, sir.
Fine. Can you see the presentation, sir? Right. I was talking about the CST Studio Suite 2024. Actually, we were here having a fine look at the modules present, I mean, included in CST Studio. These are all the modules, and we have literally counted individual submodules, which comes around 27. So we'll be having all these modules. This software, particular CST Studio Suite, is available in your college campus, your department. So there is a plan for extension of the same. So you don't have to worry about it. You have a licensed version where you can literally perform all the operations of these verticals. And we are here to guide you under each module. We will go module by module, or we can have selected number of students who are all interested to do antenna design or circuits and components. As such, we can plan and execute the training sessions as per your convenience. I mean, your academic plan is something different, so we'll plan them. Now, I wanted to show you. So we were here. I will introduce once again what are all the tools in tools for electromagnetic simulations. CST Studio Suite, if you want, you can make a note of it. Opera, Antenna Megas, all right, and WASP.NET, Fest 3D, Spark 3D, and IDEM. Okay, these are all the different simulation softwares available for electromagnetic studies, under which we will exclusively discuss CST Studio Suite. You can see all basic informations are available with the official website itself. I will just share this link on the chat section of today's meeting. Hope you can see that. There it is. I already shared. So you can check all the basic informations about CST Suite and what are all included in this CST Studio Suite. Electromagnetic solvers. These solvers are very important because whatever input that we give, they convert it into equivalent form which is understandable by the software. So we may be entering numbers literally. Assume if you are designing an antenna, we would define the length and width in terms of x and y axis, also the thickness in terms of z axis parameters, but the same will be converted into some other form which is understandable by the software. All right. So it depends on type of simulation that we select, whether it is, you see, I will give you an example here, whether it is time domain based or frequency domain based, which type of result do we expect? I am designing a system and I am going to have a clear view on it. You see, what kind of response are we expecting, whether it is time domain based or frequency domain? Okay, so that is depending on our choice. So such solvers are included. Design environment is there, which means you can select different categories. You can test a particular circuit under different constraints. Like I would like to recall one of the basics of electronics, which we call electron ballistics. Based on this electron ballistics only, the entire electronics engineering is running, that we all know. But still, I wanted to recall. Electron ballistics is the study of behavior of an electron under different circumstances. The circumstances refers to electric field, electrostatic field, magnetic field. How does the electron behave? So based on that, we categorize electron devices. We would have seen different types of electronic devices. So these devices are categorized based on a particular electron's behavior. All right. Such design environment is available. You can optimize your product, designed product. That provision is available. Assume that you are designing an antenna for 10 gigahertz, but your antenna is providing a very good result at 8 gigahertz. That means the antenna is resonating at 8 gigahertz. So if you want to optimize the antenna to 10 gigahertz, yes, you can do. You can change the parameters. I will teach you how to do that. That optimization is possible. All right. Electromagnetic systems modeling. This is project based and some workflow, different workflows. I have shown you different workflows. Like you see, these are the workflow under antenna. There are 9 different workflows, and similarly, other. You see, antenna under antenna we have 9 workflows. If we select circuit and component, we have 8 workflows. There are different workflows available. You can choose your preferred workflow. This is all about the available EM simulation tools by Dassault Systems. So where do we use this CST Studio Suite? So now we know what is CST Studio Suite. It has multiple simulation modules, correct? And different workflows available, understood and accepted. And where do we use them? How is it benefiting industries? We will see. I will give you a small video that will tell you where is this CST Studio Suite used. Check this, please. So you have seen 2 examples. One is smartwatch, the other one is lightning strike. So just focus on the examples, okay? E-bike. Okay. Have you gone through the video? Did you understand something from that video? Can you hear me? Fine. I will show some of the industrial applications of CST Studio Suite. So these are domain-based applications, but there are a lot more. I'm just showing only few of that. You see aerospace and defense, where it is used for designing and optimizing antennas, radomes and radars. Radome is the protective shield for radar or an equipment which will absorb any electromagnetic radiation. That means it is like a shield which will try to hide it from existing. I mean to say it is like a shield for the radar. Okay, that is radar. It's actually radar dome. Short form is radomes. Radar cross-section high frequency application in satellite communication. If you are good at CST Studio Suite, possibly in radar, you have that radar module also. I will show you. Sorry, it is actually here. See, radar module is available. See, under microwave and RF optical tools, you have radar applications. I will show you. You can select a particular module and start working on it, and you can become an expert in that. It is not necessary for you to understand everything in this CST software. You can choose just one under one. See, under microwave, you choose radar application. Okay, and there are these many workflows available. You start learning one by one. That is enough. You can go to small objects, large objects, as such. You see, lots of submodules are there. When we are talking about the applications, you see, for radar, aerospace and defense is using CST Studio Suite with respect to antenna design and radar. So you can select, you can plan your activity. You can start working on some concepts related to this and develop a project. Either you work for antenna field or radar. Take your pick. It is your choice. Or no, sir, I'm trying to work on automotive. Yes, you can go ahead with EMC testing. That is also possible. I will show you. EMC, you can see electromagnetic compatibility. Under that, you have these many options. You can select at least one, say radiated emission. Fine, go ahead with this. What are you going to deal with? Sir, I am going to deal with electromagnetic compatibility of cables. Okay, good. So which type of analysis? Sir, I will work with time domain. Yes, no problem. Go ahead and define your units. Select the frequency range. Start working. You can do it. So we have many modules, multiple modules. And if you are really good at EMC, then you will be observed. You will be seen by most of the automotive manufacturing companies. Telecommunications. You see 5G and 6G high frequency applications. 5G we have, 6G now we are in the verge of developing it. Okay, so fifth generation, as we all know it. So today in my training session, I will teach you how to design an antenna for 5G communication. That we will see. For telecommunication, enough. If you know a very good antenna design, I mean to say very good antenna design, which means your antenna should be very good. How do you do that? I'll tell you how. If you are good at this, then you can think about telecommunication unit, where you have lots of industries working on communication based activities and projects. Okay. And the next few applications: consumer electronics, biomedical, energy, electronics, and semiconductors. You see, so these types of industries are using CST Studio Suite, and it's your choice to pick one of this. Anyways, you're going to work in any one of these industries, and you can select from now onwards. Where am I going to be after my completion of degree? Where am I going to work? You can design now itself. You don't have to make much efforts with respect to hardware. You can do everything in simulation, and you guide engineers to do what, how to do the hardware fabrication. For example, if you are dealing with antenna design simulation, then we, after the completion of our antenna design simulation, we download the file and give it to the hardware engineer. From the file that you have given, the hardware engineer will start developing the hardware. Like antenna, he will develop the antenna. All the measurements and other basic informations will be there. All right. So this is all about introduction to simulation and what is actually the CST Studio Suite software, what are all the modules in it, and what are we going to discuss from now on. So if you have any queries in the topics or points that we discussed so far, you can ask me now. For your reference, I will run this slideshow once again from the beginning, so that if you have any queries, you can shoot. So once you are done, once you are comfortable with going ahead, we will start designing an antenna today. Please go through this presentation. This is for mechanical design, okay, physical structure design. It does not have anything to do with the electromagnetic or electrical properties of our system. Though there are some electrical sections in this, generally this CATIA is for mechanical design, GeoVia for mines and other civil infrastructures. Simulia has two members. One is Abacus, that is for civil and mechanical engineers, and the other one is CST, I mean electromagnetic simulation. Delmia for digital manufacturing. 3DVI is for additional fine tuning of the physical appearance. NetVibes related to marketing and other trends related with sales. Innovia is a platform on which other tools run, like CATIA, Delmia, all other Dassault system products run on this Innovia. 3D Excite is, the additional exciting appearance for our designed product. BioVia is for biomedical people, where there will be inbuilt chemical formulae and combinations. So they can combine them together and form a new drug also. Okay. So for understanding, I will show you about BioVia also. Give me like 2 minutes. Right now, I will show you this. Is here, you can see. This is an interesting thing because you must know what is this. You have some role to play in this biomedical field also. So I will share the link of this also. When time permits, you can have a quick look at this. This is for BioVia. I'll tell you what is in this. See, these are the modules in it. BioVia Discovery. We'll go with BioVia Discovery, under which we have simulation, structure-based design. See, these many modules inbuilt with BioVia. So for understanding, I'm showing this. We'll run this again. I've shared the link for BioView also, since it has played a very important role during the discovery of corona vaccine. You may have to understand what is this, because we need to understand, because we are engineers. So Medidata is the module in which the medical informations are stored, the clinical data are stored. This is what Dassault system does. They provide joint certification. They are good at industry connects, just like what we are doing now. This is an online session though, but we do provide hands-on in person also. The objective of Dassault system is to bring out the best of the institution. So that maybe there are 50 participants now. Few of you may be very good at antenna design. Few of you may be very good at antenna design, and few of you may be good at radar. You know what I mean? So we need effective people. Dassault system products successful partnership. Few examples we have seen. This is what we are now. I hope things are clear until now. I will summarize one more time. I have introduced you to the requirement need of simulation for today's industrial trend. For that, we understood what are the industrial revolutions so far. We are at industrial revolution 4.0. Okay, we are here. We are at industrial revolution 4.0. And for 5, we'll be collaborating with robots, for which we need high encryption standards, which we are already working on. For that also, we need simulation, because with simulation, we can develop a perfect product. Particularly, we will discuss about electromagnetic simulation. That is the objective of this event, which is being organized by your department. That is for now. If you have any queries, you can ask me now. Otherwise, we will move on to antenna design. Please ask me if you have any questions.
Sir, I have a doubt.
Yes, please.
Is the software completely free, or we need to pay certain amount to a certain feature to obtain some software?
And can you please introduce yourself? May I know who's this?
I'm Jayaprasad from King's College of Engineering, Purukulam. I'm currently pursuing final AC.
Okay. I will do one thing with the permission of Professor Gulam sir. With your permission, I will just post my contact number on the chat screen. Shall I?
Yes, you can. Yes, you can.
Because for this question, this is a very good question. I appreciate your interest. It's really good question, because to use this software, what should you do? So I need to explain you few more points. So I will just paste my number on the chat section now. It's my number. You can text me or call me at your convenient time. We will have a discussion. All right.
Yeah, thank you, sir.
Fine. I will tell you how to make use of this software. What are all the free modules available, and it is depending on the extent of simulation that you prefer. So once I understand your project idea, since it is your project idea, you cannot disclose it in this common forum. That's why I shared my number. We'll discuss about your project module, and for your module, what best can I support, I will do. Okay.
Yeah, thank you, sir. Thank you.
Great. Any question, students? All right. In that case, I will start working on antenna design. Now the time is 7:35. What would I do is, I would give you some basic informations before you start designing. Now I will assume that all the participating students are very fresh for antenna design. So we will start from basics. So what are all the deciding parameters? What should be considered, and how do you select the value of particular parameter? We'll go one by one, for which I will show a document now. We'll start from there. I hope you can see the screen. Is it visible? Yes. So now we are going to discuss about antenna design. So this is my software, CST Studio Suite. I will open to show you antenna. Next. So there are lots of types of antennas, but I am going to talk about patch antenna. As you can see, this is used in our mobile phones. I will talk about patch antennas. Next, what kind of response do I expect? I will choose time domain response. And these are the basic units. And I should define these units, but it's okay. Default units are good. You see the dimensions are in mm. I'm good with this. Select minimum and maximum frequency. If I am trying to design my frequency, antenna's frequency, like 5 gigahertz, let us say 5 gigahertz, then I want to have the response of my antenna. So my antenna's frequency is inside this range. So I can have the response from 1 gigahertz to 10 gigahertz. How does my antenna behave? Having started, I don't want to see any of this. So this is what I'm going to do. But you can see this is patch antenna, which has ground and patch layer. In between, I have a dielectric. Dielectric, we know it's an insulator, it does not conduct. As a whole, if you see this arrangement is like a capacitor, but it's not actually a capacitor, I'm telling you. So you have different parts, patch, dielectric, ground. Now it is clear. We have one more part. You see this part. Can you see the cursor, students?
Yes, sir.
Nice. So this part is feed, FEED, feed. Here is what we place antenna groove like this. I hope you can understand now. So here we connect the, this is what the antenna groove is, we call. All right. This is for testing. Okay. During the test, we have to use this. Now you can see the patch and ground are of same color. They are of same material. They are actually conductors. Can be anything, copper or some other conductor, PEC, whatever. So this is how it's going to look like. Before that, I should understand some basic parameters. So what is an antenna? An antenna, as far as our understanding, antenna will transmit signal and receive signal. Good, that is correct. Technically, it transmits signal in the form of electromagnetic waves, okay, and receives in the same manner. So whatever signal is being transmitted by our antenna, it will be transmitted at a particular frequency. If I am having an antenna, then antenna must have a frequency. Okay. If I am dealing with some RF signals, then I may have to deal with some frequencies of some few megahertz till few gigahertz. So megahertz to gigahertz band I have to deal if I am talking about RF antennas. Let the antenna, for example, sir, I want to design an antenna. Okay, you are going to design an antenna. Where are you going to use it? So your application is first priority, for which I have a chart. You see applications here: consumer electronics, high frequency design, space and defense. For every application, you have particular frequency value. Can you see? So these are all frequency levels for concerned applications. Fine, sir. You are saying that for low cost antennas up to 2 gigahertz, okay, there is a frequency level. Then what else do you have to see? First thing, application, and you decide your frequency. Step 2. Step 3, you see a dielectric here. You have to select this material. That is important. That is given here. You see substrate. For 2 gigahertz, you can either select FR4 or Rogers, because you see 1 gigahertz to 100 gigahertz also this is applicable. Up to 2 gigahertz, FR4 is applicable. So if I am designing an antenna at 1.5 gigahertz, which one I should select? whether I should go for FR4 or Rogers. Which one do I take? Both are having same frequency. Both are going to transmit and receive signals. Another important factor is this loss tangent. My dear, keep in mind, though you are working on 1.5 gigahertz, consider this loss tangent. So for FR4, the loss tangent is between 0.02 and 0.03. But for Rogers, it is 0.0009. So here you should understand, after determining your application, after selecting frequency, before selecting the material, substrate material, you should see this loss tangent. Forget about dielectric thickness, constant and dielectric thickness. You don't have to worry about these two. The important thing is loss tangent. Loss tangent is a constant which will decide the efficiency of antenna. If the loss tangent is high, the efficiency is low. If the loss tangent is low, then the efficiency is high, vice versa. Now you see these two. Which one do I prefer? 0.02 is higher than 0.0009. So I will naturally go for Rogers. Understand? Because for 1.5 gigahertz, this material, Rogers RT Durad 5880, has very low loss tangent compared to the other one. Understood? You see? So if I select this, then what will happen? I know the application, I know the frequency, I know the loss tangent, I select this material. Once I am done with this material selection, then I will use these two values. Understood? I am going to take this material. So you have proper justification for that. So and so frequency, loss tangent is low, I will select this one. Fine. Then you should consider dielectric constant and thickness. Now you make a note of these two values because you selected this material. Is it clear? So once you decide type of application and frequency, you select material, then you make a note of these two values. Here you have a range 0.2542 to 3.175. You can choose any value. Better you take average of this. It's okay. It's up to you. Because you cannot be so random. Once you are selecting here 2.000 mm, 2 mm thickness, fine. After designing, you are going to simulate it. Your antenna should resonate at 1.5 gigahertz. That we will test. If it is not working properly, again we have to come back and change the value. That's why simulation is so important. Do you understand? Did you get the point? Should I repeat? Students? Good. After selecting type of substrate, we note down dielectric constant and its thickness. Okay, let it be 2 mm and 2.2 is the epsilon r. So, for example, I am just telling this, but we will start with this one, and I have this document is prepared assuming that we are using FR4, flame retardant 4. That is the name of this material. Okay, so I have a material here. Resonating frequency. Sir, my antenna is resonating at 10 gigahertz. I designed it for 15 gigahertz, sir, but my antenna is resonating at 10 gigahertz, sir. What is the meaning? The antenna's efficiency is very good at 10 gigahertz. And if you try to send a signal at 15 gigahertz, it will not work properly. Then how is the antenna efficiency determined? How do you determine the efficiency of antenna? Actually, there are lots of calculations, but for understanding, I will tell you this. Assume that you are transmitting a signal at 15 gigahertz. It is not sent properly. You have some disturbance. Okay, the receiver side, you have some disturbance. Sender side, my antenna is not sending the signal properly. But the same antenna, if you send a signal for 10 gigahertz instead of 15 gigahertz, it is sending very well. What is the meaning? the actual signal transmitted is delivered to the receiver properly without any disturbance. That means your antenna is doing its job properly. I am Sayed. If you ask me to score 100 marks, I will not score. I will resonate at 80 marks. I am capable of scoring only 80 marks. I cannot score 100 marks. So my resonating marks is 80. Similarly, an antenna will resonate at a particular frequency. That is its maximum efficiency, which means it can sense that level of frequency signal without any loss. Okay, practically with reduced loss. Why we define this loss tangent initially. So that parameter is called resonating frequency. Okay, this is applicable for both radiating or receiving, sending or receiving. Okay, loss tangent I already told you. Okay, then we are going to talk about design of antenna. Before that, instead of using so many formulae, I will give you a shortcut only for reference, because all these formulae are available in your textbooks itself. So we don't have to spend much time on these calculations. Like I said, here, have a look at this. We are going to design this antenna, for which we need length and width of the patch. That is foremost thing. And also we need to design, we need to have the length and width of dielectric, length and width of ground. From this figure, you see the length and width of ground and length and width of dielectric both are same. Okay, keep in mind. So in this design, when we talk about width, it is x-axis. If you want, you can make a note, because we are going to use this for all the antenna design procedures. W, width is x-axis. Okay, minimum width, maximum width, or x-axis minimum, x-axis maximum. We will have to enter the value of width. And L is y-axis. Y minimum, L. Y maximum, L. Okay, wherever y is coming, we input the value of length only. And dielectric thickness or height is z-axis. So z-axis is thickness of anything, patch, dielectric, ground, any material will have a certain thickness. That should be entered in z-axis. Okay, for z-axis, we input thickness. If you want, you can make a note, because this is the basics which you should keep in mind. Okay, don't forget. Now, now what do I know? I know my frequency is 5 gigahertz. Okay, I have chosen 5 gigahertz frequency, and I have selected which one. Though it is up to 2 gigahertz, for understanding, I am just starting from this material. My frequency is 5 gigahertz. My material is FR4. I know the loss tangent value, dielectric constant. This table is generally available in internet and other textbooks also. So you don't have to worry. Anyways, I will share this information with Professor Gulam sir. You can take it for future reference. See, I am using these values. My frequency, except the frequency. Here it is 2. I can go with 2 also. See, once I know these values, I go to RF. Everything RF. Just press enter. The first website. Go inside. You see RF calculators here. Click it. Many calculations are there. There you go to antenna calculator. You see, we are designing patch antenna, microstrip patch antenna. So click it. Dielectric constant. What is the dielectric constant value? I selected this one. So this is from 4.2 to 4.8. Which value can we take? I will take 4.3, for example. Okay. What is the height? Height is the thickness. Okay. Thickness is height. H. 0.8 to 1.6. I will take 1.6, for example. Or you can take 1.4 also. What is my frequency? 5 gigahertz. Now look at this. Here you have the value. Clear? You This is in meters and this is in mm. We take the dimensions in mm. Okay, that is easier for, because it is a very small unit. If you take in meters, then you may get confused. 0.01 or 0.10 or 0.001, as such confusions may occur. So now just make a note of these values, width and length. That's what I did here. See, width and length is noted it. Okay, length is 13.92, width is 18.42. Okay, I just noted. And then I start designing the antenna. Go to CST Studio Suite. Right. Go to microwave RF optical antennas, patch antenna. I will go with time domain analysis. All units are basics. Let it be. I want to see the response of my antenna. My antenna's frequency is 5 gigahertz, but I want to see its response over a particular range of frequencies. 5, so you can go 5 gigahertz in the less than that. That means 0. You can start from 1 gigahertz, and a 5, after 5 it's 10. Around between 1 and 10 gigahertz, how is my antenna going to behave? I am going to see that. First I will design and then I will check. So initially, since we are getting started, we don't have to get confused much about E field, H field, far field and all. I will tell you all these things in future sessions. But for getting started, we will just leave the message. Just leave the message. Sorry for the disturbance. People are cracking something. And you see, this is the summary of my selection. This is the summary of my selection. And I will click finish. Now I will get the template. Okay. How it looks like. Before we start designing the antenna, I will tell you how to use this software, so that when we proceed, it will be very easy for you. So far, you have seen how to get started with the antenna design. What are all the preliminary definitions and values you should keep in mind. Now you have a basic idea about antenna, and to start this, you see lots of tools are available across this window. Whatever you create will be available on left. You see the left side components. Whatever you create, you can just move this. Click and move, it moves. If you want to change the view, then over here you can see. Select view perspective, 0, 1, 2, 3, many. These are our keyboard values. Now I will press 5. You see the appearance, it changes. 4, 3, 2, 0. For different numbers, it changes its position. Or you can simply click and rotate. Okay, fine. Let it be like this. Any design parameters that we prefer to enter, we go to modeling and then do it. Okay, in modeling only the physical structure and other properties are loaded. Here you can have brick for for creating box, sphere, cone, everything is here. So for antenna, we are going to use the brick only. Okay, brick. And once we are done with that, we go to simulation section and define the frequency of our antenna. Once again, it is already there. You see, I entered 1 and 10 already while initiating this design. Otherwise, here also I can change. Okay, actual appearance. How do you want this to be seen? Okay. So these are some of the important things that you need to know. And once you are done with all the design, look at this start simulation. If you click there, then the parameters that you have loaded already will be evaluated by the CST software. And then if there are any errors, you will get the message over here on the bottom, right bottom. All right. Now, whatever parameter that you enter will be available here. You see the parameter list, it will be available. For example, I will include only one. Now, this is the opening screen of software. After I give some basic inputs, now I am going to design. I am going to box. For this, I use this figure. I will keep this figure in mind. First, I have to place a ground layer. Ground layer is a metal. I am going to place ground layer. So for which I need the ground layer's dimension. I want the ground layer dimension, but I don't have it now. Seriously, I don't have. But I have the patch dimension, where I have the patch dimension from here. See, I calculated from here based on the technical properties. I should design a patch having width of 18.42 mm and length of 13.92 mm. So this is strict value. This is over here, you can see patch value. But have a look at this ground. It is bigger than the patch. So I can take some other big value compared to this one. If the width is 18.42, width of patch. So I will take width of ground as maybe 24 or 26. You know, I have look at this x value. X means thickness. Here I am trying to draw a ground layer using brick. I should click once, click somewhere in the box and press escape. I am going to make ground layer. I told you X stands for width. Okay. Now actual patch width is how much? 18.42. Thing higher than that for ground. It is higher than this one. Okay. So instead of in place of that value, X value is greater than patch value. 18.42 is the design value. So I will take 22. Okay. I can take 24 also, no problem. But something higher than 18.42. Reasonably higher. Now I will do X minimum. What is X minimum? I prefer 22. So minimum value, so I put minus 22 by 2. Here plus 22 by 2. Sir, why sir? Instead of 22 by 2, I know the value 22 by 2 is 11. Why don't you put 11? It is a good question, but still, for understanding I am doing this. Why did I put 11? I should keep in mind. Because there will be lots of values during the design. You will be entering too many values. You don't have to get stuck somewhere, you don't have to get lost somewhere. So I am doing this for reference. In the meantime, I am storing, I am typing the value here also. Step on ground design, I select some higher value. Okay. Similarly, Y value is 13.9, that is length. I will select 18. So 13.2 is the limit. I will select minus 18 by 2 and plus 18 by 2. This is X and Y values. Okay. Z value. What is Z value? Z value is the thickness of the ground. Okay. This ground layer should have a thickness for which I don't have the value. I will tell you how to select. Listen. After the design processes and simulations are completed, we are going to export the document. Look at this cursor on the left top corner. We will export the document to our hardware engineer, to your hardware engineer. Your company will have a hardware engineer. He will take the file from you and he will use this design file in his machine to create physical antenna hardware. Okay. So I will continue for 5 more minutes. Okay. we are just getting started. I will explain these steps in the next class also. So next class we will design a complete antenna, two different antennas. Okay. So Z max, that means how do I select? Please keep in mind the Z value will never go to negative region. X and Y may or may not go, but Z value, minimum Z value is always 0. Okay. So I am going to have a ground layer, so it is 0 minimum. Maximum is the thickness of this ground. There is a standard thickness which is 0.035. This is the basic thickness of copper clad. You can make a note, CLAD, which is used in PCB manufacturing machines. They'll be using a copper clad. It is a metal and its thickness is 0.035 mm. Now, this is component 1, material. This is a ground layer. It should be a conductor. I am going to select copper. See, the copper is not here available here. So I load it from the material library. There are many materials available. I don't have to search one by one. So I will type copper. There are two types of copper materials available. I will select copper annealed. Annealed copper is better than the pure one because annealed copper are these materials are subjected to gradual heating until a value below lesser than its melting point and then gradually cooled. For example, if copper has some 500 degrees Celsius of melting point, then the material is heated up to 300 350 degrees Celsius and then gradually cooled down. So doing this will strengthen the material first physically, and then it will have improved chemical properties and it will have better performance. There are lots of reasons you can check. Annealing, why annealing is done for copper. So I am selecting copper. See, you should justify every single value, whatever you design. Why do you select this? Why do you do this? Why do you do that? You should have justification for everything. Okay. So I select copper annealed. Once I press load, then I am good to go with this. So I will just have a preview. You can see I have just created a ground layer. Now I will check once again. Now it's fine. So I press OK. You see a layer is formed. When I go check components on the left side, component 1 is ground. Okay. So next we will design component 2. For this, we take this figure. Ground is done. I will place dielectric, patch, feed. So I have 3 more steps pending. Dielectric, patch and the feed. So I will have 3 more steps. You see, first step ground is done. Second, I will design substrate. Then I will design patch and then feed. Okay. So now we have 3 more steps to do, which we will continue in our next session. In our next session, I will start from the ground layer. I will tell you how to do it. Okay, from the ground layer, we will go ahead. We will relaunch this CST software and go from right from here. We will go. Okay, I will teach you once again in the next class how to get started with CST Studio Suite. It's loading here. From this, we will start. Okay, next class is probably on uh, 4th of this month. That is day after tomorrow, same 6 p.m. We will connect once again. I hope you have understood something about antenna, and before that, something about CST software and simulation technologies. And I believe that you have learned something out of this session. And Professor, it's actually 8:05. So I am just opening the session for some questions if you have. We are ready to design the antenna. So to get the continuous flow, I'm just saving it for the next class. So where we will start from the beginning. If you have any questions, please ask me.
Students, we will also be sharing the recorded version of this program for you to refer. So before coming to next session, you can also have hands-on training with respect to the student version. And then if you have any doubts now or even on Monday, you can just get it clarified from side, sir. So now the forum is open. If you have any doubts to be asked, please go ahead. I think Syed sir, they're all beginners. So they will
Great,
need
sir.
some time to know, take this inside their mind and then apply it. So
Sure, sure,
hopefully,
sir.
while resuming on Monday, they should be coming up with some questions.
Great,
So,
great.
so we'll wind up for today, sir. We'll resume
Fine,
on
sir.
Monday, and then we'll do some real-time design, sir.
Sure, sir. Sure. We will go ahead with physical design of this antenna, and from there, the students need to evaluate some properties that, as you know very well, we'll get started on Monday, sir. Purely, we'll go ahead with hands-on antenna design, and we'll see how it goes.
Sure, sir. Sure, sure. So, Dheeraj, over to you.
Yes, sir. Thank you, sir, for sharing your insights on the importance of simulation in the modern era, and also for explaining us about the basic design of CST Studio Suits and all other softwares of design systems. As dear friends, as you all know, this session does not end with this, and there's more to explore in CST, which we will be seeing in next session. Thank you, sir, for this wonderful session, starting with the design of a patch antenna and continuing to enlighten us about this designing process. Thank you, sir, and thank you,
Thank,
participants.
thank you, Professor Gulam, sir. We'll meet on Monday. Thank you, Dinesh, for hosting this event.
Yes,
Thank you
sir.
all.
Thank you, sir.
Yes, sir. Thank you, Syed sir. We'll resume
Thank you.
on Monday. Thank you. Thank
Definitely.
you,
Thank you.
students.
Thank you. Thank you. God bless you.
And participants kindly fill the attendance form for which the link has been posted in the chat section. முடிஞ்சிச்சுமா